Okay, so we were discussing polarization of light, and in that we were discussing dichroism or selective absorption. So today we will do Malus law and solve some questions on that. So in the last class, we were discussing polarizers based on selective absorption or dichroism. So what was a polarizer? So polarizer is a device used to produce polarized light from natural or unpolarized light. Okay, so last class we had discussed this, that we can denote natural light as like this. Okay, so what this means is that I can have the orientation of the electric field vector in any possible plane. All of the planes are possible, in fact. So we draw it like this. So this is my natural light. Now I want to produce a polarized light. So if I want to make elliptically polarized, circularly polarized, or any other p-polarized light. So first thing what I have to do is I have to generate a plane polarized light from this natural light, right? So polarizer is a device which I will use. So now what I will do is I will put a polarizer here. And I said last time that we can think of polarizer as a filter, which will only let those electric fields which are parallel to its transmission or pass axis. Okay, so each polarizer has a defined pass axis or the transmission axis. So let us say that here right now, this is my transmission or pass axis. What is this? This is the pass axis or transmission axis of my polarizer. Now it will only let that component of the electric field pass through this, which is parallel to this transmission axis. So then I know that I will get this kind of a Y polarized, or if I define that this is my coordinate system, this is X and Y, then this is my Y polarized light, which I will get. So now that I have a P state or a plane polarized state, now I can, try to make any other combination. So now I can make either RCP, LCP. So I can produce two plane polarized states with whatever orientation I want, and I can sort of, add them, and I can generate other exotic forms of polarization. Okay, so this is the most basic thing. So now another thing which you will sort of get in questions also is an analyzer, and also you might have read it also, that what is an analyzer. So analyzer is a device which is exactly like a polarizer. It is a polarizer, in fact. Analyzer and polarizer का construction में कोई difference नहीं होता है. Both of them are actually polarizers, but we just say that analyzer is an analyzer because we use it to find out that what is this state of polarization. Okay, so an analyzer is basically a device or a polarizer which is used to analyze the state of the polarization. Okay, so we can write an analyzer is an identical device, identical to a polarizer. Okay, which is used
Ma'am, which kind of device are we talking about right now? The first one were the dichromacy.
Right now, I'm just talking about a polarizer. So that can be based on any method. It
General
doesn't
polarizer.
matter. Yes, a general polarizer. But in most of the lab में जो भी experiments we'll do, or whatever in exam, they will not specify that what polarizer is there, because all of them will have the same property. Only the how nicely it polarizes, that efficiency will change with different processes, but otherwise the way a polarizer will act will be same. That you can maybe change the material of the polarizer or something you have all these ways through which you can make polarized light. So all these devices which will convert a natural light to a polarized light are polarizers. The only thing that is going to be different is the efficiency of each polarizer, but ultimately this part is same, that a polarizer will convert a natural light into a p state, and an analyzer is an identical device or a second polarizer which is used to analyze the polarization state कि light का फिलहाल polarization क्या है. So I will use another polarizer to figure out what is the polarization state. So that second polarizer is just called an analyzer because we are using it to analyze. Okay. So it's an identical device. Identical say I mean that identical to a polarizer, which is used to test the polarization state of the beam. That some light beam is coming to you and you want to find out that what is the polarization state. So you use another polarizer and you sort of, I'll tell you that how we find out the state. So now in order to, sort of understand that how an analyzer works. So an analyzer will work on Malus law. So we should know what is Malus law to understand that what an analyzer will do in fact, okay? So now I just want to make one small point, because last time when I was discussing natural light, I told you that, we can consider the natural light as a superposition of two orthogonal polarizations. That means I can decompose all these possible electric field vectors into some two chosen directions, maybe X and Y, and we can write a natural light as a superposition of these two orthogonal vectors. And when I will pass this natural light through a polarizer, then I said that we can sort of assume that one component was completely absorbed and only one component was passed. And so I told you that if I have here, let us say 1000 watt per meter square intensity is falling here. So here I will only have 500 watt per meter square. Okay. So I just want you to make a mental note here that here what we have not reduced the amplitude. Okay. Amplitude यहाँ पे कम नहीं किया. A polarizer cannot reduce the amplitude of the light. So this intensity, this drop in intensity is not because the amplitude half हो गया है. ठीक है, amplitude अभी भी E naught है. अगर मैं ऐसे consider करूं that I have E naught X cap and E naught Y cap, okay, this is some E field, and I want to find out what is E square. So that is twice of E naught square, right? But now what I have done is I have put a polarizer so that one यहाँ पे y वाला पास हो रहा है ना, तो one component is completely absorbed, and therefore now my resultant is just E naught square. So this is not because ये E naught by 2 हो गया था. Okay, understand this, that I have not changed the amplitude to half. Intensity has reduced to half because one half of the, one contributing half is completely absorbed. Okay. So just this can come like a simple, like a one line conceptual question that would a polarizer also reduce the amplitude? A polarizer would never reduce the amplitude of the beam. जो भी इलेक्ट्रिक फील्ड का एम्पलीट्यूड है वो चेंज नहीं हुआ है. ओनली वन कंपोनेंट, the one component of the beam has been absorbed, and because of that the intensity has reduced to half, not because E naught has become E naught by 2. Okay, so this has not happened, balki this has happened, that one component is being completely absorbed. Okay, so let me just write that so that
Ma'am,
yes.
Ma'am, natural light is not a monochromatic light.
Yes, it is not a monochromatic light.
So how do you like decompose it into like X and Y, like into two components? Because they have like different frequency range, and
yes, but you can do this decomposition for each frequency range. Your polarizer is going to work for a certain band of frequencies. Okay,
Remember,
it will.
Polarized light is it's a monochromatic light, right? Polarized light, it has only one frequency and constant. It has only one frequency, right?
The way we are studying, it has only one frequency. Yes.
And so like
the way it is defined, the way we get it in lab, we are always dealing with almost monochromatic beams. Yes.
So how is it done, like a natural light into a monochromatic beam?
But this natural light, I'm not, okay, I understand what you're asking. Okay. Okay, so let me think about it, okay? I'll tell you tomorrow maybe.
Okay, ma'am.
Okay. Because I don't want to say anything wrong, and right now I'm not able to think. So I'll just, if I'm able to think something right now, I'll tell you today, or else I'll tell you in tomorrow's class initially. Okay.
Okay, ma'am. No
so, yeah, what was I saying? Yes. So a polarizer can never reduce the amplitude of unpolarized light. Okay, so this is just one point for you to remember, that this intensity jo half ho raha hai, it's not because E naught has become E naught by 2, but it is because one component has been absorbed. Okay, now coming back to your question. So when I was sort of, describing this source, okay, natural light source in the last class when I was discussing. So, how was I sort of explaining this? I will just revise that for you. So it will slightly clear that what I mean by a natural source. So I said that I have all these atoms which are doing some kind of a radiative, you know, transfer. So they are falling from a higher energy level to a lower energy level, and in the process they are releasing a photon. Okay. So now let us say this photon is released and this photon is released. Like that, I have multiple photons which are being released. But if all of those photons will have different frequencies, so I cannot write, I cannot define polarization in that way. So when I was describing this kind of a natural light in the last class, what I said was that let us take those photons which are of the same frequency. So let us say this is also new one, this is also new one, but their electric field vectors are oriented in a different way. So let us say here the electric field is vibrating like this, here the electric field is vibrating like this, here it is vibrating like this. Okay, so I never considered a light with different frequencies. I considered a light source in which, there is no control on the orientation of the electric field. So the light is still like coming in a short band of frequencies only, but because I'm considering a spontaneous emission sort of process in which the photons, see, when I want to write, if I say this is my E1 field, this is my E2 field, and this is my E3 field, then I can write a E field as E1 plus E2 plus E3, that I can combine all of these electric field vectors which are oriented in different manner because they are all spontaneously emitted fields. Okay, so I can write a resultant electric field out of this, and let us say I find that it is oriented like this. But now, because everything is happening on its own, I'm not controlling anything. So after a certain time, these electrons might also change their sort of place where they are, and they might again, stop radiating for some time and then start radiating again. So maybe this wave train gets broken, and the same electron now sort of radiates another wave train, but now the electric field is oriented in some other manner. So then after that much time, which comes out to be 10 to the power minus 8 seconds, so after this time, all of these electric field vectors will sort of stop emitting what they were emitting, and they will spontaneously change the orientation of the electric field, because their configuration will change. So they will now emit the electric field in some other directions. Okay, so this natural light which I am talking about, I'm not talking about a natural light which has all of these frequencies. Okay, so I'm still talking about a light which has only nu one frequency, but it's more like a spontaneous process. I'm not in any way filtering the polarization so that only one type of orientation of the electric field is getting passed, but I'm defining a superposition so that I find out a total, I do a vector addition of all these electric fields, and I find out that, okay, this is how, at that instant, this is how the electric field is changing. But now, after this much small time, 10 to the power minus 8 seconds, all of these atoms again change their configuration, and they start they randomly change their orientation of the electric field. So then I will write another e dash e vector corresponding to now this new location of these electric fields, and maybe now I see that the superposition, ये जो superposition मैं लिखूंगी, that is oriented like this. Okay, so this natural light here, ये जो मैंने ऐसे बनाया है, this is only corresponding to one frequency, the way I defined in the last class. Okay, so it's still a quasi monochromatic source. It has a very small line width. Mostly it consists of one wavelength, one frequency actually, because I'm not adding these contributions of other colors. Okay, so this is something I sort of discussed in the last class, that this is how I'm defining my natural source. Okay.
Okay, ma'am, got it.
Okay, so here, when I'm talking that, okay, my electric field was like this, I'm talking about this electric field vector, which is a superposition of all of these electric field. मतलब basically, हर एक atom ने एक wave train release kiya hai, because I'm not talking about the photons as in a particle. We are looking through the wave picture. Okay, so each atom is releasing a small wave for a certain time period, and in that wave the electric field vector can take any orientation. I have no control on that. Okay, it's completely random. So as this wave train, jab tak ye wave train survive kar raha hai, I can do this summation, that I can take all the electric field vectors of the same frequency and add them and write a total electric field. Okay, and uska orientation, let us say ye hai E1. E1 is maybe this when I add all of them. But after a very small time period of 10 to the power minus 8 seconds, spontaneously it will change the orientation of the electric field, because now a new wave train will be emitted. And that is why I'll not have a coherent light. I will have an incoherent light. Okay, because this wave train is sustained only for a very small amount of time. The atom will undergo certain changes, and then it will again release a different wave train with a slightly different orientation of the electric field. And then I will do again the summation of all these new, not E2, I mean E dash at some new time. Okay, so again, I will do a summation of all these electric fields, and it will give me, let us say, this new orientation, which is some E dash. This was some E. Okay, so like that, if I will notice that how the electric field, मतलब ये जो total electric field है, ये जो summation वाला electric field है, ये कैसे vary कर रहा है, तो I'll see that over sufficient time, it will oscillate in all possible planes. Okay, it has no no preference to one direction. It will oscillate in all planes. And that I am writing by this, okay? So this maybe you can note somewhere that I am dealing with a quasi-monochromatic source or a monochromatic source, like, because we discussed there cannot be a perfect monochromatic source. So it's a quasi-monochromatic source which has a very small line width, or nu plus delta nu is very small. Okay, so so what was I discussing? Yes, so we have to do Malus law now. Okay, so abhi हमने क्या किया? We took the natural light and we converted into one P state. Okay, now I want to analyze that, you know, ये क्या polarization है. So I want to find out that what is the polarization state of this light. Okay, so what I will do, I will use an analyzer. So let us try that. So now I have, this is my P state. P state का मतलब है that it's a plane polarized, but it is parallel to the y-axis. So I can just make a note that it is parallel to y-axis here. Okay. Now what I'll do is I'll put an analyzer in front of it. So this is my analyzer. And अब analyzer क्या है? Analyzer is identical to a polarizer. So analyzer will also have a transmission or a pass axis. And जैसे polarizer में होता है, only that component of the electric field which is parallel to the transmission axis will be passed, and all the rest of the components will be absorbed, right? So now if I draw that this is my y-axis, and I say that my analyzer का जो पास एक्सिस है वो ये है. So basically पहले मेरा पोलराइजर y के पैरेलल था, अब मैंने जो एनालाइजर रखा है y के पैरेलल नहीं रखा है, बल्कि I have slightly rotated the analyzer so that now its axis is making some angle theta with respect to the y axis. ठीक है. So now what we do in lab is we have the freedom to rotate this analyzer. So we can do the complete 360-degree rotation of this analyzer, and I'm free to rotate in theta. Okay, so I can rotate theta and I can choose whatever pass axis I want to choose. So now what we do is, so let us say this intensity is some I naught. So this is the incident intensity. And let us say here I get some intensity I. So एक चीज तो मुझे पता है that analyzer. Yes.
Pass axis is in the pink.
Pass axis is pink, so it is still in the xy plane. Okay, so this is my x axis. Still xy plane के अंदर ही है, but I have just rotated. Okay, I'm not rotating in z. So I've just rotated in the xy plane only, so that it makes an angle theta with respect to the y-axis. Okay. So now I know that because analyzer क्या है? Analyzer भी एक polarizer है. तो मुझे ये पता है कि इससे जो भी यहाँ पे transmitted light आएगा, that is going to be parallel to the pass axis of the analyzer. ये मुझे पता है. That is the property of the polarizer, that the polarizer will only pass that component of the electric field which is parallel to its transmission axis. Okay. But now I want to find out going to be the magnitude. कि क्या मतलब यहाँ पे intensity का magnitude क्या आएगा, कि intensity क्या आएगी. ठीक है. So I know that मेरा जो original incident I naught intensity है, that is directly parallel to y-axis, and the analyzer is making an angle of theta. Okay, so I can take the component of the incident intensity along theta, right? So what will I get here? I will get I is equal to I naught cos square theta. Why cos square theta? because मैं इलेक्ट्रिक फील्ड का कंपोनेंट लूंगी, then I will square it to find out the intensity. So इसको ना इस तरह से लिख सकते हैं so that it's easier. If I say that this was some E naught, E naught was the amplitude of the electric field. So I will get E naught cos theta, and this is square of this. Okay, so E naught, what is E naught? E naught is the amplitude of E field, and my I naught is equal to E naught square. Okay, so this is the amplitude of the electric field here. So I can write then E naught square cos square theta. So I is simply equal to I naught cos square theta. So this is the Malus law, and it was discovered in 1809 by 18 Malus. So it's named after the person who discovered it. So this is a formula which you should remember. Very easy to remember. कुछ नहीं है, हमें सिर्फ ये याद रखना है. So what we have to remember is, maybe we can also put a star here, that polarizer will only pass component of E field which is parallel to its pass axis. ठीक है, so जो भी इलेक्ट्रिक फील्ड मुझे दिया है उसका ओरिएंटेशन से उसके रिस्पेक्ट में आई कैन फाइंड आउट दैट व्हाट इज दिस एंगल द एनालाइजर इज मेकिंग. एनालाइजर का पास एक्सिस या पोलराइजर, मतलब एनालाइजर बोलूं या पोलराइजर बोलूं, बोथ ऑफ देम आर द सेम थिंग, बोथ ऑफ देम विल वर्क इन द सेम वे. ठीक है, सो डू नॉट गेट कंफ्यूज्ड बाय द नेम्स. सो इसका जो भी एक्सिस है थीटा है, आई जस्ट हैव टू फाइंड आउट द कंपोनेंट ऑफ दिस ई नॉट along this axis. So basically what I have done is, यहाँ पर मेरा ये कुछ E naught है, this is E naught, and this is the component of E naught along this axis, so that is E naught cos theta. ठीक है, so simply I have found out the component of the electric field in this direction, and intensity is just the square of it. So this is my Malus law. Easy to remember, but it is important. ठीक है, Malus law पे question आता है, and it's very simple. You should not lose any marks on this. ठीक है, so now coming back to the previous main question, that how are we analyzing the polarization of the light using an analyzer. Okay, so what we do is, see यहाँ पर, because I have freedom to choose this theta, it's completely up to me कि मैं कितना एनालाइजर को रोटेट करना चाहती हूँ XY प्लेन में, so that maybe I want to choose this axis like this. Okay, I'm free to choose. I can keep on, I can do a 360-degree rotation of this. I can choose whatever theta I want. So what we do is we vary this theta, this angle, and we plot that what is the intensity I we are getting. So we make a graph on which y-axis may we plot the intensity, and x may we plot this angle theta. So basically we are making a plot that how intensity is varying as this angle theta is changed. Okay, and depending on different types of polarization states, we will get different type of curves, and just by looking at what kind of curves we are getting, we can understand that what is the input state of the beam. Not input state, what is the polarization of the input beam. Okay, so how we'll do that, we'll do a question on this so it will be clear. So basically I will plot this I here, and I'll plot this theta here. So I might get a straight line curve, I might get something like this, or I might get something like this, and all of these corresponds to different polarization states. So इसके ऊपर एक question करेंगे, तो तब you will understand. I want to make you think about it a little bit, so that's why I'm not explaining it right now. ठीक है, so जब क्वेश्चन करेंगे तब आई विल एक्सप्लेन, तो तब समझ आ जाएगा. बट दिस इज हाउ वी फाइंड आउट द पोलराइजेशन, दैट वी चेंज दिस एंगल थीटा of the analyzer का pass axis क्या ये theta बना रही है. I'll change that with respect to some axes. So I can fix the y axis or the x axis and I can vary this theta and I can plot a curve. यहाँ पर मैंने y axis के respect में change किया है because मुझे already पता था कि जो input light है it is parallel to the y axis, वो मैंने choose किया था. But in exam हमें पता, मतलब exam नहीं, experiment में हमें पता नहीं होता है, तो we'll fix one axis and we'll just vary and check. So maybe you have also done, might have also done some experiments on this. ठीक है. So now there is one more point which I want to state here. Question में दिया होता है काफी बारी that you have a polarizer and you have an analyzer and you are getting zero intensity outside. Okay. So what that means is, अगर मैं Malus law देखूं तो zero intensity मुझे कब मिलेगा? When cos of theta is equal to 0. That means when theta is equal to 90 degree. So if the light which is falling, देखो इसको ऐसे देख सकते हैं, that question में mostly ऐसे दिया होता है that you have some natural light. So basically you have all possible electric field vibrations possible, and then you have a polarizer. So they'll tell you that what is the pass axis of this polarizer. Let us say it is this. So after passing through this, हमें पता है that only this component is going to get passed. So if I say this is my polarizer P, and now I want to analyze this. So I will put another polarizer or an analyzer here. But now the question is saying, if this is my y-axis, so now the question is saying that I get 0 I here. यहाँ पे मुझे इंटेंसिटी 0 मिल रहा है. ठीक है, पहले हम इंटेंसिटीज लिख लेते हैं. यहाँ पे क्या है, अगर इसका इंटेंसिटी I0 है, ठीक है, so after the polarizer I will get intensity I0 by 2, and this is something which you will forget in the exam. लास्ट टाइम भी सब लोग भूल के आए हैं, तो मैं इसलिए बार बार बोल रही हूँ कि डू नॉट फॉरगेट दिस. अगर ये इनपुट जो है, इफ दिस इनपुट इज अ नेचुरल लाइट, यू ऑलवेज हैव टू रिमेंबर दिस, you have to reduce the intensity by half. Okay, so you will get I0 by 2 here. And now what they are saying is that this intensity that I'm getting after the analyzer, let us say the analyzer is some A, this is my analyzer, is equal to 0. So what this means is that the pass axis of the analyzer is like this, so that I'm making an angle theta is equal to 90 degree. And so I am getting I is equal to I0 by 2, because अब इस पे इंसिडेंट लाइट का इंटेंसिटी क्या है, I0 by 2 है ना, एनालाइजर के ऊपर. So I will have I0 by 2 and cos square 90, which is equal to 0. So I is equal to 0. So इस तरह का ओरिएंटेशन जहां पर पोलराइजर का पास एक्सिस और एनालाइजर का पास एक्सिस जो है, they are making an angle of 90 degree. Okay, this is also called crossed position. So this is also called crossed position. Okay, so question mein if it is written that the analyzer and polarizer are in crossed position, so it should be clear to you that this theta is equal to 90 degree in that case. Okay, and why analyzer and polarizer क्यों दिया है? Because इस तरह का कोई configuration है. So you can make a diagram in your mind that अच्छा, I have to put two polarizers basically. One of them is a polarizer, the other one is an analyzer, and the intensity मुझे बोला गया is equal to 0. That means they are at their transmission axis is making a 90 degree angle with respect to each other. So theta is 90 then. Okay, and if the question says that I am getting maximum intensity, okay, so this is case 1. So case 1 says, yaar kya bana diya? So case 1 says that intensity here is equal to 0. Okay, and case 2 says that I is maximum, मुझे intensity maximum मिल रही है. So अब मतलब question इस तरह से ही बनता है that you have polarizer and analyzer and they are placed in such a way that the total intensity is maximum. ठीक है, तो मैक्सिमम जो पॉसिबल है वो हमें लिखनी है. तो इंटेंसिटी मैक्सिमम कब होगी मैलस लॉ से? जब cos थीटा जो है इक्वल टू 1 होगा. दैट मीन्स the pass axis of the polarizer is parallel to the pass axis of the analyzer so that the complete beam passes. ठीक है, so इस केस में I is max. I'm getting the maximum intensity possible on the output. So what it is saying to me is that if my input is a natural light, so I have a polarizer here. This is my polarizer, and this is my pass axis. So if this is I naught intensity, so I will get something like this, and the intensity is going to be I naught by 2. ठीक है, अब मैंने क्या किया है, यहाँ पर I have put another polarizer, but now यहाँ पे मुझे I जो मिल रहा है, it's the maximum value possible, I max है. That means that I should be equal to I naught by 2. I naught by 2 से कम नहीं होना चाहिए. I naught by 2 उसके ऊपर इंसिडेंट हो रहा है एनालाइजर के ऊपर, ये मेरा एनालाइजर है, तो उतना एज इट इज पास होना चाहिए, उससे कम नहीं होना चाहिए. सो दैट मीन्स my pass axis of the analyzer should be parallel to the polarizer. So this should be my pass axis. So these are they are like, completely open or sort of parallel position. So the upper one, in which theta is 90, is like a crossed position, and this is like a parallel position that the pass axes are parallel to each other. So when you read a question, you have to pay attention कि अगर दो polarizers दिया है, डायग्राम नहीं बनाया है, क्या लिखा है, that you are getting maximum intensity or you are getting zero intensity out of it. That is how you will choose. ठीक है, और अगर कुछ भी नहीं दिया है तो you can choose any angle theta for the analyzer. मतलब कोई भी मैं orientation choose कर लूंगी. फिर अगर ये मेरा analyzer है तो क्वेश्चन में मेंशन नहीं है कि मुझे क्या चूज करना है. इट्स नॉट सेड कि मैक्सिमम इंटेंसिटी मिल रहा है या जीरो मिल रहा है, तो आई विल चूज एनी रैंडम एक्सिस सो दैट दिस थीटा इज देयर, एंड देन आई विल यूज द मैलस लॉ एंड ट्राई टू सॉल्व इट. ठीक है, तो अभी ये हमने केसेस कंसिडर किए व्हेन द इनपुट लाइट वाज नेचुरल लाइट. So what will happen if rather than a natural light, I will use, a P state or plane polarized light? So we already know what will happen. We will apply Malus law 2 times. ठीक है, so Malus law हम तब यूज कर रहे हैं जब हमारे पास एक प्लेन पोलराइज्ड लाइट पोलराइजर पे फॉल हो रही है. We are not using it when we are considering natural light. ठीक है, so you have to pay attention. अगर डायग्राम बना है क्वेश्चन में, तो डायग्राम में look at the input. If the input looks something like this, that all the angles, all the vibrations are shown, that means it's a natural light. Simply reduce the intensity to half and make the polarization parallel to the axis of the polarizer, simply. But if, my case 3 can be that the input is a polarized light. So let us say P state mein some light is falling. So now I already have some intensity I naught, which is now falling on my polarizer. This is my polarizer. ठीक है, so अब मैंने polarizer intensity इसको कुछ अलग शेड करते हैं. Let us say it's falling like this. ठीक है, so now I can, roughly draw a line parallel to this. And I have some theta is there. Okay, so then I'll write that, okay, अब यहाँ पे मुझे क्या मिलेगा, I'll get light outside which is parallel to the axis of the polarizer. So ये जो मेरा input intensity था, उस पे I will apply the Malus law, and here I will get I naught cos square theta. This is going to be the intensity of this light which is passed. Now I will apply an analyzer to it, and depending on the pass axis of the analyzer, let me choose the pass axis of the analyzer as something like this. Okay, so this is my y axis, and now this angle theta is there. So now what will I get? अब ये जो y axis है, इसका एक और component मुझे लेना होगा. ठीक है, cos theta. So अब मतलब पहले I naught था, वो अब छोटा हो गया. Intensity after passing through this has become I naught cos square theta because I have taken one component of this. ठीक है, I've taken that component which is parallel to the polarizer axis, but now I have another analyzer here. या एक और analyzer है. So what I will get is now I'll get light which is now, you know, plane polarized along the pass axis of the analyzer. And what will be the intensity? Intensity हो जाएगा I naught cos square theta. And let us say this is not theta, this is some angle phi. Okay, so this will be cos square phi. Okay, इस तरह से I can put as many polarizers and analyzers I want to, you know, put. कितने मर्जी भी configuration हो सकता है. So बस I have to pay attention to the fact that with what input am I starting? Am I starting with the natural light? Then I have to keep into track this root, मतलब not root 2, this dividing it by 2. ये half का factor मुझे याद रखना है. If not, if I have a polarized light which is you know, falling onto my polarizer, then I have to apply Malus law each time. जितने भी polarizer, जितने भी analyzer दिए, I'll have to always take the component of the field, you know, in the direction of the pass axis of the polarizer. ठीक है, so अब कुछ questions कर लेते हैं. 10 ही मिनट रह गए. थोड़ा अंडरस्टैंडिंग तभी आएगा. Let us try this question. So this is a question from JAM 2016. Okay, so the question is saying that in the optical arrangement as shown below, the axes of two polarizing sheets matlab polarize use kar hai, P and Q are oriented such that no light is detected. Okay, कोई light नहीं आ रहा है, ये P और Q दो polarize मैंने रखे हैं. Now when a third polarizing sheet R is placed in between P and Q, then light is detected. Then which of the following statements is R true? So there are 4 statements and out of which 3 are true. Okay, so take your time and check. So first you draw this diagram under ये सोचो मैंने अभी बताया what does it mean that no light is being detected? Means that P and Q are in crossed positions. फिर मैंने एक और थर्ड पोलराइजर डाल दिया है, बट ये मुझे नहीं बताया कि थर्ड पोलराइजर का ओरिएंटेशन क्या है. सो आई विल चूज सम रैंडम थीटा एंड आई विल जस्ट पुट अ थर्ड पोलराइजर इन बिटवीन दीज टू. So which of these statements are now true? It's a completely conceptual question. If you understand Malus law, if you understand whatever I've taught today, you will be able to do it. Okay, so I have 4 answers. So let me check the options. Rajat, your answer is correct. Adrish, your answer is correct. Mansi, your answer is correct. Dhruv, your answer is correct. Naman, your answer is correct. Very good. Okay. Very good, all of you. Okay, so I'll give maybe 2 minutes more.
मैं MS
क्या?
ये MSQ है.
हाँ, 3 options are correct here. कुछ कैलकुलेट मैंने ऑलरेडी बता दिया, 3 ऑप्शंस करेक्ट है, तो पढ़ के भी बता सकते हैं. इसमें एक ही ऑप्शन दिख रहा है साफ साफ जो गलत है अकॉर्डिंग टू द क्वेश्चन इटसेल्फ. संचित, योर आंसर इज करेक्ट. अक्षदा, योर आंसर इज करेक्ट. वेरी गुड. ठीक है, तो कितने लोगों ने कर लिया? 1 2 3 4 5 6 7 लोगों ने कर लिया. लेट 1 पर्सन मोर सॉल्व इट. कौन है क्लास में भैया? एक इंसान और सॉल्व करो. Okay, Ratan, no, one option is not correct, beta. 2 are correct. ठीक है, करते हैं इसको जल्दी से. So यहाँ पे क्या लिखा है that the two polarizing sheets are there and they are oriented so that no light is being passed. So what this means is कि ये मेरे पास कोई P है और मेरे पास Q है. अब Q का ये मैंने पास एक्सिस बनाया है, ठीक है, पोलराइजर का. राइट नाउ दिस इज द पास एक्सिस ऑफ द पोलराइजर and the pass axis of Q is like this. This is Q. So I am getting zero intensity. I is zero now because the pass axes are in a crossed position. So no light is getting passed. Doesn't matter input kya hai, unpolarized, polarized, kuch bhi ho, they are in cross position. So I'm not getting anything. So now what the question is saying is that we insert another polarizer in between P and Q. So यहाँ पर randomly मैंने choose कर लिया that let us say this is the polarizer R. तो ये जो मैंने blue में draw किया है that is the pass axis of the polarizer. So this is making some angle theta with respect to y axis. तो मैं coordinates draw कर लेती हूँ. This is my x, this is my y. ठीक है. So I can simply, मतलब इतना करने की जरूरत नहीं है, but I am just doing so that in exam तो हम नहीं करेंगे इतना. We will have the understanding, but now because we are learning, so let us see. So यहाँ पर कुछ मेरे पास इनपुट हुआ लाइट, ठीक है. यहाँ पर मेरे पास अनपोलराइज लाइट आ रहा है. सो लेट अस से दिस वाज आई नॉट. सो आफ्टर पासिंग थ्रू, तो अब जो रिजल्ट आ रहा है ना हर प्लेन पे, वो मैं ऑरेंज कलर से ड्रॉ कर रही हूँ. तो ये पोलराइजर पी में से पास होने के बाद मुझे पता है दिस इज गोइंग टू बी माई पोलराइजेशन स्टेट, ठीक है, पैरेलल टू द पास एक्सिस ऑफ पी एंड इंटेंसिटी इज गोइंग टू बी आई नॉट बाई 2. ठीक है, दिस आई कैन अंडरस्टैंड. अब मेरे पास आर कोई दूसरा पोलराइजर है विच इज प्लेस्ड एट सम एंगल थीटा. सो देन आई नो कि अब यहाँ इससे पास होने के बाद जो मेरा polarization है वो will be parallel to the pass axis of R and the intensity will become I naught by 2 cos square theta. ठीक है. सो अब मुझे फाइंड आउट करना है टोटल इंटेंसिटी यहाँ पर I क्या आ रहा है मेरे पास. तो अगर अब मैं इसके पैरेलल एक लाइन यहाँ पे ड्रॉ करूं पास एक्सिस ऑफ आर के. सो दिस एंगल इज 90 माइनस थीटा. ठीक है. सो देन आई विल से दैट आफ्टर पासिंग थ्रू दिस आई विल गेट लाइन, मतलब लाइट विच इज नाउ पैरेलल. ये हटा रही हूँ मैं एक सेकेंड के लिए. सो आई विल गेट द आउटपुट लाइन लाइट विच इज नाउ पैरेलल टू द पास एक्सिस ऑफ माई क्यू. सो मेरा फाइनल जो लाइट है उसका पोलराइजेशन ये हो गया. And intensity will be I naught by 2 cos square theta, this whole thing multiplied by cos square of 90 minus theta. ठीक है. So this is what I am going to observe on the detector. Detector पे मुझे polarization मिलेगा x polarization according to this diagram and this is the intensity I am going to get. So हमें बताना था कि which options are correct. So polarization axis of P and Q are perpendicular to each other. ये तो question ने ही बोला है, so it's correct. Then polarization axis of R is not parallel to P. ठीक है. अगर हमें R अगर P के पैरेलल होगा तो उसका मतलब क्या है, फिर से लाइट जीरो मिलेगी, है ना. तो this is also correct that R is not parallel to P and polarization axis of R is not parallel to Q also because वो Q के भी पैरेलल होगी तब भी हमें जीरो ही मिलेगा. तो ये तो मैंने पूरा एनालिसिस कर दिया है, बट इस क्वेश्चन को तो हम सिंपली पढ़ के भी कर सकते थे. फिर लास्ट है कि पोलराइजेशन एक्सिस ऑफ पी एंड क्यू आर पैरेलल टू ईच अदर. तो नो, दैट इज रॉन्ग बिकॉज क्वेश्चन में ही दिया है दैट दे आर इन अ क्रॉस्ड पोजीशन, सो द एक्सिस आर नॉट पैरेलल टू ईच अदर. ठीक है. सो ये जो मैंने पूरा सॉल्व करके दिखाया है, इससे यू कैन सॉर्ट ऑफ विजुअलाइज दैट हाउ you are sort of changing the polarization of the light, but in the process you are also losing intensity each time. Okay, so just to make a mental note of it. So let us do another question. Sorry, क्या खुल गया ये. Let us try this. This is a question from JAM 2020. So the question is saying that a beam of unpolarized light of intensity I0 falls on a system of 4 identical linear polarizers placed in a line as shown in the figure. So input kya hai? Make a mental note, not a mental, in fact, highlight it in your copy because this is where you will make a mistake. So just highlight it. It's an unpolarized light. So unpolarized ka matlab hai that it is something like this. Okay. So this is falling on 4 polarizers. The transmission axes of any 2 successive polarizers makes an angle of 30 degree with each other. So every time the transmission axis 30 degree se rotate ho raha hai, theek hai? So if the transmitted light has intensity I, then the ratio of I by I0. So this is I0 input intensity. We have to find out the output intensity. So basically you have to apply Malus law. ठीक है, so इसको solve करो. Adrish, your answer is correct. Very good. Rajat, very good. Okay, so we have 2 correct answers already. Dhruv, your answer is correct. Sanchit, your answer is not correct. Please check. Diptanshu, your answer is not correct. Please check.
मैम फाई जो होता है वो थीटा के रिस्पेक्ट में होता है ना, दो पोलराइजर्स में.
मतलब फाई तो मैंने ऐसे ही लिख दिया था. That is simply
नहीं
an
जो भी
angle.
था, हाँ जो भी एंगल है सेकंड वाला जो हमने मेजर किया था फाई, वो हमारा फर्स्ट पोलराइजर के पास एक्सिस के रिस्पेक्ट में है ना.
हाँ. Naman, your answer is correct. Mansi, your answer is not correct. Mansi, you have made the mistake. You have not done I0 by 2 after the first polarizer. नहीं किया ना मानसी?
नहीं सर.
हाँ नहीं किया. मुझे पता है सब लोग यही गलत करते हैं, इसलिए ये क्वेश्चन में ऑप्शन नंबर सी दे के रखा है ताकि जल्दी जल्दी में सब लोग ये टिक करके चले जाए. सब लोग यही करते. तुमने लास्ट बैच में भी एवरीबडी वाज लाइक दे डिड द क्वेश्चन रॉन्ग बाय डूइंग दिस. मालस लॉ सबको याद रहता है, ये याद नहीं रहता है कि इनपुट बीम को थोड़ा देखें कि क्या दिया है. दैट इज द, इसलिए मोस्ट ऑफ द क्वेश्चंस में अनपोलराइज्ड लाइट घुसा देते हैं इनपुट में, बिकॉज स्टूडेंट्स यूजुअली इट्स नॉट इन द प्रैक्टिस टू रिमेंबर. ठीक है, सो इसको करते हैं. 9 बज गए, यही क्वेश्चन करते हैं, बाकी क्वेश्चन फिर कल कर लेंगे. ठीक है, सो कहाँ पे, इसी में ड्रॉ कर दूँ, इसी में कर लेते हैं. सो लेट अस से कि फर्स्ट पोलराइजर का पास एक्सिस ना ये है, या फिर नया फिगर बनाऊं, नया ही बना लेते हैं. सो द इनपुट बीम व्हिच इज कमिंग is this of I0 intensity. ठीक है, now it is falling on my polarizer. This is my polarizer. So I am choosing key, this is the pass axis. I'm starting with the axis which is parallel to Y right now. So then जो भी output है, I'm drawing it in orange, and जो भी axis है polarizer का, that I'm drawing in green. ठीक है, just a notation to remember. So now I will get here this light output में. ठीक है, and the intensity I'll get is I0 by 2. This is the intensity I'll get. So next क्या बोल रहे हैं? Question is saying that the transmission axis of any 2 successive polarizers make an angle of 30 degree with respect to each other. So now if I choose my second polarizer, एक second polarizer मैं यहाँ पे डाल रही हूँ अब, तो इस polarizer का जो पास एक्सिस है वो पुराने polarizer के रिस्पेक्ट में 30 डिग्री रोटेट हो चुका है. तो अब जो मेरा पास एक्सिस है वो कुछ ये है, ठीक है. So that this angle is 30 degree. ठीक है. So now what output I'll get an output which is going to be parallel to now this axis, and the intensity is going to be equal to, if I say this is I1 is equal to this, so this I2 is going to be equal to, this is my first polarizer, this is my second polarizer. So I2 is going to be equal to I1 cos square 30, okay, which is equal to I0 by 2 cos square 30. अब मैंने एक और तीसरा पोलराइजर यहाँ पे प्लेस कर दिया. अब जो ये पोलराइजर है, इट इज, इसका जो पास एक्सिस है, इट इज नाउ रोटेटेड बाय 30 डिग्री विद रिस्पेक्ट टू द पोलराइजर नंबर 2. तो पोलराइजर नंबर 2 का पास एक्सिस ये वाला था, इसमें और 30 डिग्री मैंने इसको रोटेट कर दिया. सो दिस विल बी समथिंग लाइक दिस, सो दैट नाउ this angle with respect to y is equal to 60 degree, but with respect to the second polarizer, this angle is, second polarizer किससे draw करूं, second polarizer was this, ठीक है, यहाँ पे रखा था, this was, this angle is 60, but this angle, ये मेरा polarizer 2 है, ये polarizer 3 है, this angle is 30 degree. Right, so then I know अब जो input polarization है वो ऐसे आ रहा था, अब वो और 30 डिग्री रोटेट हो जाएगा. So it will be something like this now, ठीक है, और 30 डिग्री रोटेट हो गया वो. So if I say that this is my I3, so I3 is now equal to I2 cos square 30. So I2 is equal to I0 by 2 cos square 30 का भी स्क्वायर हो गया ना, यहाँ पे दो बार हो गया cos square 30. और फिर मैंने क्या किया, आई हैव पुट अ लास्ट पोलराइजर, ये मेरा लास्ट पोलराइजर है यहाँ पे. अब इस लास्ट पोलराइजर में जो मेरा पास एक्सिस है वो और 30 डिग्री रोटेट हो गया. तो दिस वाज द पास एक्सिस, वेट, so this was the pass axis of the last polarizer. ये नहीं था यार, गलत बना रही हूँ. ठीक है, तो अब क्या है, इसमें 30 डिग्री रोटेट होके 30 डिग्री रोटेट होके this was parallel to this now. ये था मेरा पहले, this was my third polarizer, but now I have rotated it further by 30 degree so that now it lies like this. ये 30 डिग्री जो कि लग नहीं रहा है, but this is 30, and ये जो मेरा y axis था ओरिजिनल, अब ये एंगल 60 हो गया है, जो कि होना भी चाहिए, because we are, this is 60, sorry, because we rotated it once by 30, then again by 30, and then again by 30, right? So this is my fourth polarizer, और यहाँ पर the pass axis is now parallel to the x axis, ठीक है. So अब मेरा output में मुझे क्या मिलेगा, this is what I'll get on the output beam, which is parallel to the x axis, and I4 is going to be equal to I3 cos square 30, so which is going to be I0 by 2 cos square 30 का क्यूब हो गया. तो just put the, अब हमें निकालना क्या है, we have to find out this I4 is actually equal to I in the question, ठीक है. So then I is equal to I0 by 2 cos square 30 a cube. So we have to find out what ratio of I by I0 निकालना है, I by I0. So I by I naught is simply equal to this. Cos square 33 by 2. So I have a half. And cos of 30 क्या होगा? बताओ क्या होगा? Under root 3 by 2. ठीक है. So cos square 30 is going to be equal to 3 by 4. So this is 3 by 4 into 3 by 4 into 3 by 4, which will come out to be equal to 27 by 128. Okay, so this was the answer. Sanchit, your answer is correct. Ratan, your answer is not correct. Akshada, your answer is not correct. So now you must have noticed कहाँ गलती किया था. ठीक है. So यहाँ पर मैं बता देती हूँ. सबसे बड़ा गलती यही होगा that you will forget this I1. ये वाला जो स्टेज है, ये वाला जो स्टेज है, यहीं पे गलती होगा सब लोगों का. बाकी मतलब मैं ये पता है क्यों आउटपुट पोलराइजेशन ड्रॉ कर रही हूँ. सो दैट इफ इन द क्वेश्चन दे आस्क यू दैट आउटपुट पोलराइजेशन क्या है, सो यू ऑल्सो नो दैट. इंटेंसिटी तो हम मैलिस लॉ से निकाल लेते हैं, ठीक है, बट आई डू नॉट वॉन्ट यू टू गेट कन्फ्यूज्ड कि आउटपुट मुझे कौन सा पोलराइज लाइट मिला, पी पोलराइज लाइट मिला, बट पैरेलल टू व्हाट एक्सिस. Okay, so that's why I'm drawing this, so that you have a certain sort of visualization that how, you know, these polarizers are changing the axes. ठीक है. So बाकी questions कल कर लेंगे. अभी थोड़ा वो हो गया है. कल मैं देखती हूँ if I can take the class at 7:30. आज मैं बहुत लेट हो गई थी आते आते. I almost reached home at 7, so I had to read also a little bit, so इसलिए लेट हो गया. बट अगर कल मैं 7:30 बजे नहीं ले पाऊंगी तो I'll try to take a extra class maybe on Sunday. ठीक है, because we have to finish this. बहुत टाइम से हम ऑप्टिक्स पढ़ रहे हैं, so I want to wrap up your course so that you know you don't have to keep on reading this after a long break, because then you lose touch. ठीक है. सो आई होप यहाँ तक समझ आ गया होगा. ये थोड़ा इंपॉर्टेंट टॉपिक है और बहुत इजी टॉपिक है. मैलिस लॉ के क्वेश्चंस में कोई गलती नहीं होनी चाहिए. इट इज सिंपल, एक्सट्रीमली सिंपल. दो मार्क्स के क्वेश्चन आते हैं. ये 2 मार्क का क्वेश्चन है, ये भी 2 मार्क का क्वेश्चन है. तो मतलब इसको थोड़ा ध्यान से समझ लेना. अगर कोई दिक्कत है तो प्लीज आस्क मी राइट नाउ, बिकॉज बाद में जब क्वार्टर वेव प्लेट, हाफ वेव प्लेट भी ऐड हो जाएगा अलॉन्ग विद द पोलराइजर. सो at least this much should be clear to you, okay, before we add other optical elements to the mix. Okay, so I'll stop the class now. So good night and bye bye.
Good night, ma'am.
Thank you, ma'am.
Good night. Bye.